Welcome to the wonderful world of compass and true bearings. Oh my god, I know, I'm excited too. Who doesn't love to have compasses, to help you get places? First thing you're doing with these ones is make sure you've actually got your compass drawn so you've got an idea of where you're heading. North is that one at the top, and we're not eating any soggy Weet-Bix around here. Now, our northeast is directly in between the two. If that was at 90 degrees, that makes half of it 45. And our compass bearing is going to be north 45 east, because we're going up towards the north and then angling off towards the east. Same thing's happening for our northwest, but of course it's going to go to the west 45 rather than the east, because it's, that other direction. We love other directions. Directions are fun. Exactly the same thing's going to happen with our southeast and our southwest. Of course, the north now is changing to the south. We've still got 45 degrees for each of them because we've got 90 degrees in each of those little sections. That's why they're called quadrants, because they make up a quarter of a circle. Da-da-da. Never would have guessed it myself. Oh wait, no, I did. Never mind. When we're looking at our other ones, what we're going to do is check which quadrant it is in. So for this one, it's in the quadrant between north and east, so our letters are going to be N and E, and then we've got how many degrees it is away from our north. Next one up, north to west, so N and W, and same thing for our degrees. Doing that pretty much for all of them. The only one where you're going to start looking at something different is if you look here, the degrees isn't on the right side, it's not on the south side of that angle, so we need to actually check what that other half is going to be. Knowing that the whole thing's 90, we've got 90 minus 33, and that's going to give us, of course, 57. Woo! Who doesn't love 57? I don't. It's not my favourite number, I'll be honest. My favourite number is 4 though, so it's very far off. Same thing happens every time when one of those angles is in between where east or west is. You are looking for the angle from north or south for each of these, because we think that that's more important, because tops and bottoms, etc., rather than left and right. It's just conventions, like most things in maths, I guess. Now, hopefully by this stage we've really gotten down pat the idea that, right angles are 90 degrees, etc. And that's pretty much it with finding our compass bearings. These ones down here, you don't have the rest of your axes. Draw it on. Yeah, it doesn't change, even if it's not there. You can draw it in, and you know where your 90 degrees are. Work out which quadrant we're in, and keep going from there. Of course, if it's over 90 degrees, it's no longer going to be in that northeast quadrant. It's now in the southeast quadrant, because it's gone past east, because it went over 90 degrees. This right here, this is my shocked face. And we know it's gone 8 past, which means it's going to be the 90 minus the 8, which is, of course, 82. Hoping that we can do simple subtraction. If we can't, you've got a calculator, use it. It's very helpful. We do like to have our calculators. Same from the other ones. If you're not sure which quadrant it's going to end up in, quite literally draw your quadrants on. If you're still not sure because it's really close on, add up your degrees until you get around. Each of them should hopefully be relatively easy from there. And last couple going. Okay, the question actually asked us to do that with our compass bearings and our true bearings, so now we're back to our true bearings. Of course, we are always going clockwise, we are always starting at north, so let's see how far around we go. That first one was really just 45. It's a 3-digit number, however, so 045 degrees. Now, northwest we know was 45 degrees from the north, but on the other side, which means we actually have to go all the way around the circle. I know, I'm shocked. This right here, you can't see it, but it's my shocked face. You're very familiar with it, it happens a lot. Now, I'm sure you can, again, do that really simple subtraction, but if you can't, calculator! Woo! They're our favourite. All of our answers here should, of course, be in 3-digit numbers, because we do love 3-digit numbers for true bearings, otherwise they're just not true. I'd call them false even. I make my own fun, it's fine. For all of them, if you are getting stuck with them, draw them. Drawing is my favourite thing, well, beyond maths and a few other things, but I like drawing. Drawing's good, it helps. I'm a very visual person sometimes. All these ones working out all the way around from north, all the way around clockwise. Clockwise is so called because it's the way the hands go on an analog clock. If you don't know what that looks like, I don't know where you've been for, what, like 16, 17 years, however old you are now, but good luck, I guess. Remembering for each of these, our quadrants are 90 degrees, so if you've gone past a couple of quadrants, add your quadrants on. If you've got, like this one here, when we went all the way back to north 63 west, we do just take the 63 away from the 360. Hopefully it should be easy enough for you. Again, calculators are your friends. We like them. They're very useful. If you don't think they're useful, I feel like you're using them wrong. I don't know. It could be. Maybe you are using it right and the calculator is just wrong, but I'm going to go with probably you've typed the wrong thing in. Yeah, anything's possible, I guess. Now, the only thing I can see getting that much more complicated from here is when you don't have your east, south, and west. But like we did with our compass bearings, draw them on. They're not changing. They're always going to be in the same place. Nothing complicated is going to happen there. I promise. You can just draw them on. Really. I'm watching you. Actually draw them. I can see you not drawing them. Do it. Do it. You won't do it. You're scared. There we go. Except, you know, a couple of you still haven't. Still watching. Always watching. Now, hopefully we are getting a little bit around there. These ones at the bottom actually should be easier, if you remember how clockwise works. Again, it's a clock. Pretend it's a clock. Straight around from north, we've got our first one, 59, is a 2-digit number, so we're going to chuck that. What's that on it? Oh yeah, it's a 0. Yay, 0, 59. The other ones we are minusing from 360 if they are on that western side of it, giving us our final answers. And the ones that do come straight around from clockwise, well, guess what? The answer's actually just written there. You just have to rewrite it as your answer. Like, oh my god, look at that. Just did it. Same thing. Nothing changed. What? Again? Really? No way. That's so much fun. Wait a second, this is back on the west side. What are we going to do? 360 minus the 250? No way. Oh my gosh, what could it possibly be? Hey, got it. Now remember, if you are drawing these ones, make sure you are using a protractor, because without it, like, you're just guessing, and whilst guessing can work out well for you sometimes, it's not going to really be the greatest idea in the end, to be fair. Like, it'll be a roundabout, but not quite. Now, Aaron's going for a run. Who doesn't love going for a run? 7.2 kilometer run? This guy's crazy. Okay, they've given us most of the information. We just need to work out where all these things are. And let's have a look. We know the direction he's gone. There's 7.2 kilometers. That is that red arrow. The east is along that east line. But hey, guess what? We can also use this bottom bit here because that's already a triangle. Oh, we just made a triangle. Yay! Guess what kind of triangle it is? It's a right angle because east is perpendicular to north. Perpendicular, of course, meaning it goes at 90 degrees. Let's redraw our lovely triangle over here so we can see it a little easier. Put all our numbers on. Wait a second. Don't we know how to do stuff with right angle triangles? Like that trig thing, maybe? Oh my god, we do too! Now we've got a hypotenuse and an opposite, and I'm pretty sure that means that we're going to use sine. Chuck those in the right places. And then guess what? We've just got to get x on its own. And then calculators are our friends. So that's 7.2 at the bottom. We're just going to times both sides. So 7.2 times sine 45 equals x. Chucking into my trusty calculator. Calculator, calculating, calculators, calculating. And there we go. We are going to 1 decimal place, so make sure you put them into 1 decimal place. Beautiful.